Okay, so we're going to compare strategies. Our first thing is to fill in the probability of a win, loss, and overtime in regulation time if our strategy is to not foul. So in order to calculate the probability that we win in regulation time if we do not foul, we can focus on just that part of the tree diagram that pertains to the strategy do not foul. And to calculate the probability that we win, we must identify all paths that lead to a win in regulation time. So here's one. So we can calculate the probability along that path. And then we have one other path which leads to a win in regulation time. So we have two such paths. And of course, this one leads to overtime. So we calculate the probability along each of these paths individually. So we get 0.76 plus 0.05. And this one is 0.76. We add the probability of those two paths, and we get 0.81. So that's the probability that we win in regulation time if our strategy is not to foul. What about the probability that we lose in regulation time? Well, we can see that this is negligible. In fact, it's zero if we follow the diagram. So there is no path corresponding to this in our diagram when our strategy is not to foul. So that probability, by our best estimate, is 0. What's the probability that the game will go into overtime if our strategy is not to foul? Well, that's going to be the probability of this purple path, which is the only one which leads to overtime in regulation time. And that probability is the product of the probabilities along this purple path, and that we've actually filled in here in purple, but it's difficult to see, but it's 0.19. It should be 1 minus 0.81. Now suppose our strategy is to foul. Well, the picture is much more complicated. Lots of other interesting things can happen, but nevertheless we just have 3 possible outcomes in regulation time. Either we win, or we lose, or the game goes into overtime. What's the probability we lose in regulation time? Well, I have to identify all paths which correspond to this, and you see I've highlighted them in blue. There are only 2. This one and this very long one. Sorry, this one goes all the way down to here, which is a loss in regulation time. So I multiply the probabilities along these paths, and then I add both of those probabilities, and my probability is roughly 0.001, still very small. What's the probability that I win in regulation time if my strategy is to foul? You can see there are lots of paths leading to a win. Some of them share branches, but nevertheless they're different paths. So here's one. I would multiply the probabilities along that path, and that gives me one path that leads to a win. Here's another. It's got 3 steps. I multiply those 3 probabilities, and that's something that I'm going to add to the probability of the first path. Here's another one. It has length 4. Multiply the probabilities along there, and I get another probability to add to my previous 2. So in all I have 1, 2, 3, 4, 5 paths which might lead to a win if my strategy is to foul. When I add the probabilities of each of those paths, I get about 94% probability of a win in regulation time. And lastly, we can calculate the probability that the game will go into overtime if our strategy is to foul. So we see we have 3 purple paths here leading to overtime in our diagram, or in the part of the diagram where our strategy is to foul. And when we calculate the probability of each of those paths individually by multiplying probabilities along the path, then add those three numbers, we get the probability that we go into overtime is about 0.05. So now we have two probability distributions based on our possible strategies. One strategy is to foul, and one strategy is not to foul. And we can see that we need to calculate the probability of a win. We need to estimate the probability that we're actually going to win or lose in overtime. Now, Coach Fenlon says that the opposing team is likely to have more momentum if they have success in the final seconds of regular time, so they're more likely to win in overtime. But let's be conservative here and set that probability at 50-50. And that's being generous about our probability of winning in overtime. So how do we calculate our overall probability of winning for both strategies? So I suppose our strategy is not to foul. Well, we've already calculated the probability of winning and losing in overtime in regulation time. And then to our diagram, we add the probability of winning in overtime and losing in overtime. And now our overall probability of a win is this 0.81 plus the probability of winning in overtime, which is the probability we go into overtime in the first place, times our 50% chance of winning in overtime. On the other hand, if our strategy is to foul, then we have about a 94% chance of winning in regulation time, plus this 5% chance of going into overtime times the probability, the 50% chance of winning in overtime. So with the strategy foul, the probability of a win overall is about 97%. And the strategy, if our strategy is not to foul, our probability of winning is high, but it's not as high as the probability of winning with the strategy of a foul. It's about 90%. So Coach Fenlon concludes it's always best to foul. Now you might say, what if we change the probabilities here? What if the probability that we won in overtime is less than 50%? Okay, so we've seen that the probability of winning with the strategy foul overall is greater than the probability of winning with the strategy do not foul. If we were to change the probability that our team wins in overtime to something less than 0.5, then the probability of winning with the strategy do not foul will always be less than 0.905. So if you look back at your tree diagram and put in 0.4, you're going to see that no matter what you do, the probability is going to be less than or equal to 0.905. On the other hand, the probability of winning with the strategy foul is always going to be greater than the probability of winning in regulation time, which was 0.94. So there's always going to be at least 0.04, 4% difference between the probability of winning if you foul versus the probability of winning if you do not foul. Again, I emphasize that these probabilities were compiled from national statistics for NCAA basketball. There may be different statistics in your particular league if you're coaching, or there might be different statistics based on the strength of the offense and defense in the particular teams playing. So feel free to substitute your own probabilities for your own particular situation.